Hi everybody, welcome to on Mathmax tutorial. Today we have seen different types of integral and today is integration example is integration e raised to 2x in bracket 1 plus sin 2x divided by 1 plus cos 2x bracket complete dx. Okay, if you want the simple solution to watch video till at the end. Okay, let's do start. Okay, as first we can write the given integral as I is equal to integration e raised to 2x in bracket 1 plus sin 2x and also divided by 1 plus cos 2x bracket complete dx. Okay, we think about the which method is suitable for this example. Here we observe, here observation is 2x present, here 2x present, also here 2x present. Okay, here we can use the substitution method. Okay, here substitute 2x is equal to suppose theta and differentiate this function, we get the dx is equal to d theta by 2. Then this integral as we can write e raised to t in bracket 1 plus sine, sorry, this is the theta and 1 plus this is sine theta we can write and divided by 1 plus cos theta d theta by 2. 1 by 2 is the constant term, get here outside and integration becomes e raised to theta in bracket 1 plus sine theta, but we know that 1 plus cos theta is equal to related formula for 1 plus cos theta is equal to, also we can write 2 cos square theta by 2. Okay, then this integral becomes, we can write here 2 cos square theta by 2 and here d theta. We can now the separation, the term becomes, we can write as e raised to theta and this is 1 upon 2 cos square theta by 2, then plus this is the sine theta and divided by, we can write 2 cos square theta by 2 bracket complete d theta. Yes, okay, here we can, here the using half angle formula, but here we know that sine theta is equal to also half angle formula. We can write sine theta is equal to sine 2 times sine theta by 2 into cos theta by 2. Yes, okay, then this integral becomes as, we can write 1 by 2 integration e raised to theta, then 1 by 2 cos square theta by 2, that means this is 1 upon 2, we can write sec square theta by 2, then plus sin theta, we can replace the value 2 sin theta by 2 into cos theta by 2 in terms of 2 sin theta by 2 into cos theta by 2 and divide also 2 cos square theta by 2 bracket complete d theta. Yes, here we observe the term 2 get cancel and cos theta by 2, this is the single term, here 2 times, that means this is one remaining term, that means this is cos theta by 2, and but we know that sin theta by 2 and divided by cos theta by 2 is equal to, we can write tan theta by 2. Yes, okay, therefore above integral becomes as 1 by 2 integration e raised to theta 1 upon 2 sec square theta by 2, then this is the plus term and plus tan theta by 2 and d theta. Now here we observe, this is, suppose we can consider, suppose this is f of theta and here the derivative present, that means this is f dash theta. Yes, okay, the function as consider f of theta is equal to, suppose this is tan theta by 2 and we can find the derivative for this function, then we get the 1 by 2 sec square theta by 2. Yes, okay, and we know that this related formula for the integral is integration e raised to x f of x plus f dash x dx is equal to solution, we can write e raised to x and function f of x and plus is the constant of integration. Therefore we can write here, this is the 1 by 2 constant e raised to theta and this is the f of theta plus c, that's mean 1 by 2 e raised to theta and f of theta is equal to, we know that this is the tan theta by 2 and plus c is the constant of integration. Now here back foot theta is equal to 2x. Therefore this integral becomes theta is equal to back foot, we know that this is the 2x. Therefore 1 by 2 e raised to 2x, and this is tan theta is equal to 2x divided by 2 and plus is the constant of integration, and there is 2 to get cancel, and final solution we can write e raised to 2x into tan x and it divided by 2 and plus is the constant of integration, and this is my final solution. Yes, okay. And if you like and then share, subscribe my channel. Thank you for watching. Bye bye. Yes.